Hey, I'm Chris from 93870A. I wanted to go over Robert because our county decided that we should not go to Worlds. Well, they banned all out-of-state field trips, so that's cool. Robert is our second robot. We had Coco over there, but then I took it apart. We don't talk about that. Simple traybot. We didn't have a lot of time to make him. We made him between regionals and states. That's like 3 months, and our complex traybot didn't work. So the intakes are, well, it's a 4-motor drivetrain, 1-motor tilter, and a motor on each intake. So super simple. It's a 12.5-inch square drive base because we wanted to be able to, ride the walls and stack. That turned out pretty well. We were happy with it. The only thing that was an issue was turning because you have such a small distance between your wheels. That was messed up. And also, odometry was messed up, which is not fun because we did all the calculations and such. But the drive base is kind of sucky. In theory, it shouldn't be bad because it's just direct drive and then sprockets linking them. This chain's kind of loose, but that's okay. The problem was that our school doesn't have high-strength omnis, so we have like 1/2 inch of backlash on the wheels. The regular traction wheels are fine, but that was not cool. So our autonomous was pretty inconsistent. We had a 9 cube planned. I'll probably post that sometime if I get a day to work on that, but it was too inconsistent because of these stupid wheels. I just scratched myself. That's fun. Our tilter is 100 RPM, 1 to 7. I'm going to enter the program so I can operate that. We have our Auton selector. I made this with somebody's button library. I forgot. It's very cool. It works well, so that's nice. You see our anti-tip just shot out there. That would be because... Oh, that's cool. We have it... this pin is zip tied to the tilter. It's very jank, but it works very well, and it gave us no problems. It's just on a linear slide. If we were to do this again, and we actually were going to, as you can see right here, but anyway... I would have them on either side because we actually can't align ourselves to the back wall, which kind of sucks if we were going to do prog skills or, yeah, that's pretty much it because our Auton is decent enough that it doesn't need to align. It's a 2.75-inch Omni. There's a 2-inch screw that goes through like that. You can see the head over here. It's a screw joint. We had to make this super compact because... the nylock is too big for us to be able to put it there. We were very close to going out of spec in this dimension, which was a fun journey to solve. But this ended up working actually pretty well. And there's flat bearings on the bottom here. So the only shortcoming I would say of this design is that you have standoffs that connect the slide to the chassis, which is jank and not good, and I would not recommend it. Yes. The intakes were, they're intakes. I think this is a 24 and an 18. It's like the second biggest size and then the size below that. We funneled them because our robot has a lot of trouble stacking diagonally in the small zone, which was bad for autonomous. They're on a screw joint here and then a hinge in this dimension. We had 3 doubled up number 64 bands. So there's a lot of compression on them. They overheat after like 3 stacks. Oh, there's the scratch from before. Very cool. They overheat after 3 stacks. It's fine for matches. Driver control was a pain. Or a driver practice, sorry. But I don't do that, so I don't care. We had really high shoulders because there was a pretty random chance that the cube would just kind of, shake itself out during autonomous, which was not fun for consistency. You can see this big gaping hole here. Pause. This was for the cube lock. We had a cube lock that worked, but the traybots or the complex traybots intakes were bad. This was for a line sensor. We decided to relocate it here. It's mounted on a 1x angle. This is a really good place to mount them because with this one, since our intakes are not perfectly parallel to the tray, the cube will be like above the surface of the Lexan by like ½ inch. So this would get really bad readings. So do it by the side if you're a time traveler. Hinges are, I think these are from 8059 or 8059. They are, we decided to use a 3x. They originally had a 2x like this. This one wasn't here. We had to box them because we used so many rubber bands on the tray that they just bent in like that, the C channel, and it cracked once or twice, mostly on the bottom stage. But we just decided to use 3x so we could box it. There's a 1x angle here to prevent the rubber band from, you know, entering the mechanism. And then these standoffs on the tray are for, well, you know, to make sure that it stays roughly straight. You can add spacers in the middle here like we did. These were on our original robot, so they're super, I'm guessing when we have to take this apart, these holes right here will be super stretched and like eroded and such. We have inverted C channels because they look nice. This one is the same design. We had to do a little bit of work to get it to, that's fun, to get it how we wanted to in terms of straightness. We ended up, it's a pretty similar design. You screw in the channel on either side of these holes, box it, but then you also have to put some spacers on this screw head, which is ultimately what straightens it, because it can end up like this when you deploy, which is not good. Also, we put spacers there because these are super eroded and yucky. We could have swapped them. We would have if we went to Worlds, but haha. We used pulleys for rubber bands. They're just on screw joints. That was easy. There's not anything significant about that. License plates were super easy. I think we stole this from some team in like middle school, and you know, now we're at Worlds, so whatever. They're just standoffs with flat bearings on them. These are horrible and they're super tight. This one is not, everything else is. So that was AIDS to do in state quals back to back, but you know, whatever. Tilter is, sorry, I have to use 2 hands for this. All right. Oh, okay. We have an 84 tooth and a 12 tooth. This is a 100 RPM motor, so the axle just goes through there. That's easy. Both sides are on screw joints. They're not fun to set up because you have to get the nylock, you know, in there. Anyway, they're not that bad. We use a gyro for turns. We got the gyro late season because we didn't think we need it. That is not true. Yep. Cortex is mounted on, you can see 1x angle there, as well as some a C channel to get this, you know, so you can have holes on either side there. Our battery is all the way at the back. The robot is, well, as you can see, the tray goes past the wheelbase, so it's really easy to tip like this, and it does that really easily. We originally had our battery tucked away in here, which was, 1, bad to get to, and 2, made it super imbalanced, so that was not fun. But this is better. I think that's the whole robot. There are some build quality things that we could have made better in terms of actually designing a robot. A complex traybot would have been a better design. We don't really have time for that. So that's it for the hardware. Software-wise, we have functioning odometry. It's not on the robot right now because it doesn't work well in terms of this robot's sensorage. That's a word. This backlash is not good for trig, believe it or not. Auton selector is very simple. You just select your color and then what type. That's easy. When you hit play, it calibrates the gyro, and then brings up the logo from the SD card. That's fun. We have a stack macro, which came in very handy because a lot of the teams in North Carolina are not quick at stacking, or they do it manually or whatever. Scuff controller, by the way. One of our members has a 3D printer, so we decided we may as well. Stack macro, it goes like that. It's just a tilter P-loop and then goes... There's no rubber bands on the tray. I forgot about that. Okay. Yeah, so that was it. We can make it quicker. We decided to make it safer instead, which was the better call. We had an issue where when it would go up, it would get stuck because our bias in the P-loop was too low. We have an abandon button for that, which is always fun. I'm not 100% sure why our intakes aren't doing a thing. We have an auto indexing feature in a stacking game, imagine. Essentially, when the cube line is, or the cube line sensor is, I think it's greater than 60%, the intakes will spin this way at like 15% till it's covered, and then they'll hold. That just makes it so the driver doesn't have to think about, position of the cubes in the robot. That's nice. Our autonomous uses a P-loop in addition to another function that we're not ready to share with everybody yet. I don't know. I'll talk to my coder or math guy about that. But essentially, it makes it ramp up and ramp down, but you don't need to use slew rate or anything. That's fun. What else other than that? I mean, that's pretty much it. Code. It's just a bunch of if statements. TM. So yeah, that's Robert. We're going to take him apart shortly after this. Bye, Robert. Bye, Bex Forum.